Good morning, Varenda. I am going to explain today the radar systems. So, in this radar systems, we are going to discuss with the FMCW and CW radar systems. So, we will see what is CW radar system. So, CW stands for continuous wave radar system, whereas FMCW stands frequency modulated continuous wave radar system. Okay, so here we can see the differences between these two, FMCW as well as CW. So CW is the continuous wave radar system, FMCW is the frequency modulated continuous wave radar systems. Here CW radar system is going to find the velocity of the radar system. In order to FMCW, the velocity as well as the speed of the radar system we are going to find out in the FMCW. That is the difference between these two. Okay, so we will see what is a simple antenna where we are transmitting the signal from any radar station. So let's see one simple antenna which is consisting one radar a radar which is going to transmit the signal in the air. So how the signal is going to transmit through the antenna throughout the radar or throughout the space? How we are going to reflect back the signal and how we are going to get back the signal and how we are measuring the parameters of the radar systems. Or for example, if you are transmitting any signal that may be in frequency. So whatever the transmitted signal is there, it is having some sort of frequency. The frequency is considered as f of t. That is, the small t stands for transmitted frequency, f of t. So same like that, one object is detected. For example, one building is there. One building is there. The transmitted signal is reached in the building and collided with the building and reflected back. The same signal is reflected back to our antenna. So what is going to do? What is happening? So reflected signal is considered as f of t plus or minus f of t. So this d stands for deviation of the frequency. Deviation in the frequency. So transmitted signal plus or minus f of t. That is called as the echo signal. So this reflected signal is called as a echo signal or echo signal, we can call it as. So whatever the transmitted signal f of t is collided with the target or object and reflected back the signal or the frequency is f of t plus or minus f of t. So that will be reached our antenna. So however, we are going to calculate the frequencies based on our Doppler effect. So Doppler effect states that whenever the deviations in the signal or whenever the deviations are there in the frequency, that will be recorded continuously with the same time or different times. So that is called as a Doppler effect, deviations in the frequency. So whatever the deviations we are transmitting in the air, whatever the transmitted signal frequency as well as received signal frequency will be recorded in our transmitter or receiver antenna. So here we are using only single antenna. This is used for transmitting as well as receiving. So this antenna is going to connect with the duplexer. That is going to transmit the signal at a time and receive the signal at a time. That is the use of the duplexer. So if you want to use two antennas, there is no need to install duplexer. Okay. So whatever the signals we are transmitting, receiving, this is totally based on the Doppler effect. Using the Doppler effect, we are going to differentiate all the frequencies which are recorded in our transmitter or receiver, and we are going to find the velocity as well as speed of that particular object. If the target or object is moving, we can find out the speed of the velocity of the target as well as the distance of the target also. moving away from, just a minute. If the target, if any target this is the target, if the target is moving away from the our radar system, then we are going to take ft minus ft, transmitted frequency minus deviation in the frequency, ft minus ft. If the target is reaching towards our radar system, if the target is reaching towards the radar system, then we have to calculate as ft plus ft. So this is the difference. This is the calculation of the frequency where target is moving towards the radar system. Then we have to calculate, take as ft plus fd. The summation should be there for the transmitted signal and deviated signal. Whereas if the target is moving away from the radar system, then we have to take as a negative sign, that is ft minus fd. So like this we are going to differentiate the frequencies. As long as we are going to record all the frequencies where we are going to fetch our velocity of the target as well as location or the speed of the target. Okay, let's move to another point. So drifting the frequency due to Doppler effect. Drifting the frequency in the Doppler effect. So here the same radar system is going to place here, and we are going to find out the range. The same radar system we are going to place here, and we are going to find the target. We are going to find the target moving towards the radar or moving away from the radar. We need to find it. So once the transmitted frequency is ft and reflected back frequency is ft plus ft, because the target is reaching our radar system, so the distance is reducing. So here we are going to see what is the distance between our radar system to target. So this is the distance between radar system as well as the target. This is called as a range. This is called as a range of the radar system. So like this we are going to find out the transmitted signal as well as reflected back echo signal will decide the range of the target. Wherever the target is located or the position of the target, we are going to find the deviations in the frequency. That is the main difference between normal Doppler effect as well as drift in the frequency due to Doppler effect. So here the range will be calculated with r plus r. That means the signal, whatever the signal we are transmitting from the antenna, that has to travel up to the target, that is with the distance r, and the same signal has to be reflected back to our radar system with a distance of same range. So here our distance we have to travel, and reflected back signal also it is going to travel with the same distance, that is r. So the total distance is r plus r, that is 2r. The signal which is traveling from the transmitter antenna to our target and target to our transmitter antenna, receiver antenna, that is r plus r, that is 2r. This is the distance our frequency is going to travel. Based on this we are going to find out the range of the